Hello everyone, welcome to PJ Chemistry channel. My name is Swami. Children, last video I hope all of you observed that continuation. Today we are going to discuss. Last video we completed till classifications of matter. Ancient philosophers, Indian philosophers, they classified as a five elements, which is called Panchatattva. Next, modern classification, Greek philosophers further classified matter into two classifications based on their nature: physical nature, chemical nature. Okay, that continuation. Today we are going to discuss about physical nature of matter or physical property of matter. This physical property of matter, if you observe, matter is made up of particle. How matter is made up of? Matter is made up of particles. So matter is made up of particles. How we are going to prove? If you take a brick, if you hammer on brick, the brick break down into smaller pieces. Still, if you are hammering continuously, that may become powder form. Still, you are able to continuously beating on that. That becomes very smaller particle. That means the brick which were there, strongest stone like, through hammering, we can able to break it into smaller pieces. Means the brick made up of particles. Uh, if you take water, take water with a beaker, 50 ml of water, add some rock salt. Rock salt already you know. Okay, that rock salt when you add it to the water, what happen? It will dissolve into the water. Will it uh, as it is appearance? No. If it dissolves in water, it becomes smaller pieces. That we are not able to see also it is there in water or not. Okay, that means every matter is made up of particles. Next property, the particles are how much smaller? Particles are how much smaller? To that, one more activity. Take 5 beakers with water. First beaker take 100 ml of water. Second beaker, remaining all beakers take 90 ml of water. There is no fixed volume. You can take first beaker, more volume remaining all. Compared to that, 10 ml less. You take it and add any colored compound. Okay, I am taking potassium permanganate, adding into this water. When we add it to this water completely changes to pink color. Clearly you can observe pink color. Okay, from that 100 ml water, I am transferring 10 ml water into another beaker. What happened at the time? The same color appearing here also, but not this much thickness. That color little bit changed. Again, I am transferring from second beaker to third beaker 10 ml of water. That color still more disappearing. Like that continuously when I transfer, if you observe fifth beaker, there is no color. That means color is present here also, but we cannot able to see with our eyes because the particles are becomes that much smaller. Okay, through this activity we are going to say. So particles are how much smaller means that is up to your imagination. Very small, which we cannot able to see directly. Okay. Next, one more property: particles of matter moving continuously. Particles of matter moving continuously. How we can prove this particles of matter moving continuously? Now this is the summer. You come from outside with full of sweat. Immediately we will switch on the fan. At the time we feel very cool because that air flowing on us. It is touching to us. So the particles are moving. And there are different examples. For example, in a house, mother preparing your favorite dish. You coming from school, when you enter into the house, immediately your favorite food, no, you will feel it, that smell. Yes, mother prepared in the kitchen, but you feeling from certain distance. That means the gas is moving through air. Okay, the smell is transferring up to you. That is we call diffusion. Spontaneous mixing. Spontaneous mixing of gas are called diffusion. Okay, you just room spray. Just we spread in a room in one corner, but the room spray you will get entire the room because that spray gas spontaneous mix with the air and moving along with the air. So that is we call diffusion. Diffusion is the word spontaneous mixing. Okay. I like that many examples. Take one more activity like to prove the particles moving continuously. Take beaker, two beakers, with water. Now in first beaker I am taking honey. In second beaker I am taking ink. After I added just without disturb, I left some time. After some time, if you observe, what you will observe, which will diffuse fast, which will move fast, enter the water. Can you guess? Good. Ink. Because ink is lighter than honey. Means ink is lower density than honey. Okay. And have ink having less density, so it can able to move fast, enter the water, and it will dissolve in this. But honey having more viscosity and more density, due to that it will take more time. Honey will take more time to dissolve. Both also dissolve in water, but honey will take more time. Okay. In this way also means, yeah, diffusion is depends upon the weight of the substance, density of the substance. Lower density, more diffuse. More density, less diffuse. Okay, like that we can say particles of matter continuously moving. Next, I hope you understand this all. And one more children, based on temperature also diffusion. Temperature is more, diffusion is more. Okay, spontaneous mixing is more. Like that, take two beakers. One is with normal water, one is with hot water. In both cases, first one is normal water, second one is hot water. So in which water diffusion particles movement is more? Means obviously hot water. In hot water particles movement is more. Yes. Fourth property, particles having space between them. Particles of matter has space between them. has space between them. Particles of matter has space between them. This how to prove particles of matter has space between them means, for example, air, air, well-known example, everyone experiencing. Air is also matter, but because of space between the particles, we can able to move freely. Yes, like that, particles having space between them, we can say. Based on this space and attraction here, relation, maximum questions from this between these two relations only, space, attraction. The fifth one is particles of matter particles of matter has attraction between them. Particles of matter has attraction between them. See how to say particles of matter has attraction between them, space between them. These both are inversely proportional. When the particles having more space, they having less attraction. So space or that space, another name is interparticle space, also we can call interstitial space also can call. Okay, the space or interparticle space, interparticle space. Some books they used to give interstitial space also. Okay, so interparticle space is inversely proportional to attraction between the particles. Attraction between the particles. This, if you remember, through this only we are going to say the existence of matter, physical state of matter. That may be solid or liquid or gas. Okay. Interparticle space is inversely proportional to attraction between the particles. Therefore, more space, less attraction. Less space, more attraction. Based on this matter existence. So, based on this information, based on these 5 physical properties, matter existence mainly 3 types: solids, liquids, gases. Modern existence 2 more: plasma state, Bose-Einstein condensation. This we are going to discuss its continuation. Before that, some relations I have to give. Noted children, everyone having here clarity? What is meant by interparticle space means the space between the particles are called interstitial space or interparticle space. Interparticle space is inversely proportional to attraction. Now, what relation between the temperature and interparticle space? Temperature and attraction. Temperature increases. Attraction between the particles decreases. Solid ice cube, if you heat that, what happen? Slowly it will start to converting into liquid. Okay, means why? Initially the attraction is more between the particles. Because of heat, that attraction going to decrease. So temperature is inversely proportional to force of attraction. Force of attraction. Force of attraction between particles. This keep it in the mind. Force of attraction between particles. Temperature is inversely proportional to force of attraction between the particles. If temperature rises, attraction decreases between the particles. If attraction decreases between the particles, interstitial space increasing. Okay, so one more relation. Temperature is directly proportional to interparticle space. Interparticle space. Temperature is directly proportional to interparticle space. Interparticle space increases, attraction decreases. Yes. Next, what about kinetic energy of the particles? Means continuously moving. One property we discussed now. There, temperature rising, particles moment also rising. Means diffusion is more. Okay. Temperature is directly proportional to kinetic energy. Movement is nothing but kinetic energy. Particles moving, kinetic energy increasing. More, more heat, more movement. Next, this is only temperature is directly proportional to diffusion. Also, you can say temperature is directly proportional to diffusion. Temperature rising, kinetic energy increasing. Kinetic energy increasing, particles movement is more. Okay, like that. These are the some relations. Till now, whatever we discussed, physical properties of matter. Thank you, children. If you have any doubt, you can WhatsApp me.